The next speaker is Larry Biehl, and he'll be telling us a little bit more about the GABS work, specifically focusing on remote sensing analysis on HUBzero.
Well, welcome everybody here. I'm going to be covering a tool that has been around for a while as far as a workstations type application, but this is a tool being developed, being adapted then for remote sensing analysis on HUBzero. And I list the names of the students, Abdur, Wei Kong, and Sung Tai, who have been helping working on this project. This is a project, a part of the GABS program that Carol talked about earlier. I'll be going over the background, current status, how to access the tool. It is available now, and do a demo of it. I do have a video, but I'm going to be brave and try and do it online. We'll see how that goes. And a little bit on the outreach that has been done and in plans in the future. So what is MultiSpec? It's a freeware processing system for interactively analyzing multispectral, hyperspectral images. So when I say, how many's familiar with remote land use, remote sensing? When I say multispectral, how many people understand what I'm saying? Okay, we got a few that do that. I'll be showing an example of Landsat data. For those that are not familiar, this has 10 spectral bands. So you think of the camera in your cell phone as you take pictures of, it's got red, green, blue. It's got 3 bands, and that puts together your color image. Well, Landsat has got 10 multispectral bands. So you think of it in order of short wavelength to long wavelength. It's got the blue, green, red, but then it goes out in what's called the near infrared, middle infrared, the thermal infrared, which is parts of the spectrum that our eyes are not sensitive to. So it's got 10 bands, or you can have hyperspectral data. When they split those things up like very fine, you can have 20, 30, 40 in the visible range, plus many other called hyperspectral data. So this is the software to be able to visualize and analyze that data. It is not meant to compete with the Imagine, the Envy, ArcGIS, the commercial packages, but it gives the basics for doing that. It's been available on the Macintosh and Windows platforms for teaching, research, and K through 12, particularly for the GLOBE program. In fact, the GLOBE program helped fund the Windows version of it. And then we've been working for a while on a Linux version using WX widgets. And once we've done that, it makes it much easier then to make it a part of the HUBzero platform. And so that's what we've done here. We call it web-enabled it for the GABS project on my GeoHub. And it's used for remote sensing pattern recognition for image analysis training, the fundamentals of it. It can also be used, plans on the My GeoHub, can be used in workflows so people can take images in multispectral. You can output the images into a picture, a red, green, blue type picture that then can be put onto some of the other viewers being developed as a part of GABS. Because it can take in data, integer, real data, 8-bit to 64-bit data values. It can input that. So to give you a little bit of background, when I show it, MultiSpec, it handles 2 different kinds of images, the way I call it. Your multispectral image, and that's the one on the left. In other words, the data, the colors there actually represent the measurement in the data, the radiance that's like been reflected up from the crop canopies or emitted in the thermal wavelengths. So in this case, this is a color infrared image. It's got the green part, it's got the green, red, and near infrared portion of the spectrum being displayed as red, green, blue. Vegetation is very highly reflective in the near infrared, and the near infrared is being put on the red gun, therefore green vegetation shows up a bright red. This is a macene. So what's been shown there are the trees that are leafed out. The cropland area, this is around Lafayette area, Tippecanoe County area, is more of the grays to the light blues in it, and that's the fields, the bare soil. The crops are not up high enough to really show a lot of green vegetation. The middle one, the image on the right, is what I call thematic mapper image, and the data values there actually refer to a class of some type, a category. So that number 1 in that data value will point to some color. So it's not a measurement per se, but it's a class, a thematic class. And then there's the text output where all the text output documentation goes, the metadata for the analysis. These are features that are currently available. It uses the GDAL library for handling many different image type formats, multispectral, thematic images. It can reformat, change images to different file formats. It currently can do the unsupervised classification, or also called clustering, principal component analysis. And again, it can output, it can save a picture that's on the screen, it can save it as a red, green, blue image for input into other applications. So at this stage, what I'm going to do, okay, I'm going to bring up the browser, and that's not what I wanted. So this is my GeoHub. And if you're on my GeoHub, you can go to Resources, and you go to Tools, and under the Tools section, there's several tools out here available now on my GeoHub. One of them is MultiSpec. And so I'm going to bring up the tool page itself, sort of the launch pad for it. And there's several tutorials that are available for people to download or access PDF files to show how to do certain operations. And we can launch the tool. It brings it up on the website. We'll go ahead and open up an image file, just a standard browser image type. And let's go ahead and we'll select an image out of the input file that is set up. A user can upload files if they want. This is a Landsat 8 image. Display dialog, you can see this image is about 1,100 lines, about 1,100 columns. And one can specify which of the 10 channels are applied to the red, green, blue gun. We'll just take the default, and that is our color infrared image for the Tippecanoe County area. The black end is the Wabash River, Lafayette, West Lafayette. You can also then, let's say we want to look at a different set of channels. And this will be more of the visible range. So this will be more what our eyes are more accustomed to. Here the green vegetation is more of a greenish color. This is from a satellite orbiting several hundred miles above the Earth. One can zoom in on the image. Here's the Purdue University Airport. And you can roam around on the image. One can select an area on the image, and the number of pixels selected is shown up here, but one could say, I want to see that area in acres, and that tells you, because we have the map projection, I selected an area that's 520 acres, and you can show it in different, the location can be in different units depending on what the map projection of it is. Okay, one wants to do some analysis of the data. One could do a cluster operation. Let's do an ISO data, of which this will be an iterative process. And we'll want to cluster the entire area, not just the selected area. I'm going to do an overlay so one can see this occur real time and then save it as a file to disk that can be opened up later. The results can be opened up later. We're going to save this file, that output file, and now what's it's going, every iteration, there's 10 classes. It assigned 10 classes across this image space, and it assigned each pixel to each of the closest class. Then it recomputes the mean, goes through the pass again. And it's going to continue until 99% of the pixels do not change class. So now, what we see on the top here on an overlay is it's essentially a classification. Unsupervised, we just let the computer just group things to the homogeneous areas together. And so each of these colors would represent a different spectral class in the scene. And the user can turn this on, see what the data is behind it. I won't go into it now. We saved a file on disk that a guy could bring up with a legend on, etc. So that's one of the analysis capabilities that one can do with it. Another is some principal components analysis, in which case we're going to run this over the entire image. Principal components is a way of sort of taking the data and transforming it excuse me, to a linearly new channels that are linearly uncorrelated. It's going to try to put as much of the information in the first channel as possible. It can be considered as a data reduction type of an algorithm. We're going to save this transformation. It's gone through the entire scene, all 10 channels, 1100 by 1100. And in the text window here, that's the transformation matrix. These are the eigenvalues. This implies that the first new channel here represents 81% of the information in all the 10 channels. A user can then go in using my hands get the shaking here. Okay, we go into the reformat processor. One can use this to convert the data to different file format, different data organization, the band format. What we're going to do is transform the data using the principal channels from the principal eigenvectors. One has a choice here to adjusting the channels. You can do an algebraic transformation of the channels, function of the channels, so different ways of reorganizing the data for whatever your research is. So in this case, we're going to take that original data, we're going to save it to a new file, transform it, and we're going to save this to new file to disk. Again, the output here tells you a little bit about what happened, whether any of the data values were saturated, tells what the minimum value was and the maximum value in this new data set. So this is a whole new data set representing the same area. And this will be and we'll display this image. We have to find the min and maxes. This would be the histogram. So this is this new data set, channels 543. Let's look at it in a different way. Let's look at these channels side by side. Different view. Okay. And so now we have channel 1, next to us channel 2, and as we go down through the channels, as you get farther down, you'll see they'll become noisier and noisier as you get down to channel 10. Most of the information is in the beginning of it. So a principal component analysis that a user can do. Just one other image to bring up to illustrate. I mean, what I'm showing here is multispectral data. This is a little bit different kind of multispectral data. And this is going to be I talked about this a year ago this time, the GDD project, or the GDD data used for the U2U project. And so what I've got here is a data set of accumulated GDDs. It's got 365 bands, one band for every day of the year. So the first band represents how many GDDs have accumulated for this area for day 1, January 1st. Then January 2 is the sum of the first of the 2 days. And this is corn growing degree days. And I'm going to look at this in let's go to about day 100, sometime in April. And we're going to sort of fix, I've got to display it first. So this is an area, can't really represent, understand where this area is at. So let's go ahead and throw a vector on top of this. Let's do the state. Okay, now we have an idea where it is of the Midwest, the 12-state area being used for the U2U program. And so the colors in red down here represent the farther south. There's more heat units, more growing degree days that have accumulated as of day 100 than have been the north, as one would expect. One can change and look at the next channel, just hitting the arrow keys. And if you want to, if you just hold the arrow key down, you sort of have an animation of how the growing degree days are accumulating through the season. Again, we're looking at the top, we're calling it a day of the year. So there's some of the things that one can do, the few things that one can do with the tool on the web as it is now. Let's go back to... Some of the things that have been done, the tool was used this summer for a Globe teacher training workshop that Steve Smith did in Earth and Atmospheric Sciences. There was 8 high school teachers involved. We had them online using this tool. It worked out well. We never had any crashes, never had any problems with it. It set up some tutorials that they followed through, and they were trying to set it up and then come up with ideas how they might be able to use this in the high school during some of their presentation or sciences or whatever. I have a couple. I'm part of the America View program, director for Indiana View, and there's some in it that do a lot of outreach, and they're planning on using it in their classes in the fall. They're going to try it out to see. And I'm trying to develop ideas for next year for Indiana is the bicentennial. It's been 200 years since the state was founded. And the GENI, Geographer Educators Network of Indiana, Kathy Kozinski, heads that up, is doing quite a bit to highlight that program for the state next year in the classroom. So there's ways we're developing county data, Landsat data for each of the counties that the school systems can use, relatively small, that they can work with. Items to be aware of with it, one needs to set up an account, and you need to do this ahead of time. So a teacher just can't go in and one just start it up. It used to sort of be that way, but unfortunately, we got people trying to take advantage of it and get an account. They got disk space, they start uploading data, so now there's a delay in that. Also, you want to be careful, large images. I have used an entire Landsat scene, 7,000 lines with 7,000 columns, but it's sluggish. At home, I have it's a wireless link to an elevator 2 miles away, about a megabit is all that it's got, so up to 1,500 lines and columns works well, even at that slower one. Plans for the future. I want to be linking it to iData. Some work was done this summer that's going to allow an API that make it easier to do that link. Work going on now with a classify processor with several different algorithms and drawing graphs of selected points. And those are going to be included in the next update. They're well on their way. And then several other things to finish it out The plan is to be pretty much exactly what we've got on the desktop versions now. Questions? Any questions? Yes.
So the primary data is in raster format, right? So when you run the classifiers, or the classifiers you have right now over that, and you cluster the raster pixel or grids or whatever into larger cells, can you then export that out like maybe as a vector instead? Because
It's not done as a vector. The output is another. Well, it can either be a GeoTIFF file or a .lan file, but it is another raster file that's output. I know what you're meaning. Now you want to draw the boundaries around those, and the tool it's remote sensing tool centric. And that's more of a GIS. So, but it don't have that capability to do that.
Other questions? If not, thanks again, Larry.
Yep.
Very
Thank
good.
you.